You ever look at a skyscraper or a huge bridge and just wonder, what's holding all that together? Well, it's millions of welds, these tiny, super strong connections. But here's the secret, the thing most people don't know, the strength of that weld, it's pretty much decided before anyone even strikes an arc. It all comes down to one thing, the prep work. So let's dive into our roadmap for today. We're gonna cover the foundation, the difference between joints and preps, how to shape the perfect edge, those crucial measurements, how to choose the right plan, and that final all-important check. You know, the best way to think about weld prep is like laying the foundation for a massive building, right? If you get that foundation wrong, even by a tiny bit, the whole structure is compromised. Any mistake right here at the very beginning puts everything that follows at risk. And the stakes are incredibly high. See, bad prep doesn't just mean a weld looks ugly, it creates hidden defects inside the metal. And those defects can lead to cracking and, you guessed it, catastrophic failure. This is why getting this step right is absolutely 100% non-negotiable. All right, to really build on this idea, we've got to get our language right. We need to understand the legend on our blueprint, so to speak. So let's clarify two basic terms that people mix up all the time. Getting this down is key. Okay, so this is super important to get straight. On the left, joint type. That's literally just how you arrange the metal pieces. Are they flat against each other, overlapping, in a corner? Simple. But weld preparation? That's the fun part. That's how we actually shape the edges of those pieces. You know, grinding them into a V-groove or U-groove to get them ready for welding. So, now that we know we're talking about shaping the edges, let's look at the different designs we can use. Think of these as different architectural plans. You wouldn't use the same plan for a doorway as you would for a support column, right? Same idea here. And this shows a really smart strategic choice welders have to make. On the left, you've got single-sided preps. They're perfect for thinner metals or when you can only get to the weld from one side. But look at the right. For really thick, heavy-duty stuff, you use a double-sided prep. This lets you weld from both sides, and that saves a ton of time and expensive weld metal. Ah, this single V. If there was a Hall of Fame for weld preps, this would be the first one in. It is the workhorse. You see it everywhere on steel plates because it gives you this awesome balance of strength and accessibility for the welder. So what happens when that steel plate gets really thick? Well, a V shape would get super wide at the top, and you'd waste so much time and material filling it. The solution? The U shape. See how those sides are curved? It keeps the groove narrower, making it way more efficient and cheaper for those heavy-duty jobs. Now, just like any good blueprint, the magic is in the dimensions. You can't just eyeball these shapes. Let's dig into the critical measurements that have to be absolutely perfect. First up is the bevel angle. This is the angle we grind into the edge of the plate. Its main job is pretty simple. Create enough room for the welder to get the electrode deep into the joint so everything fuses together just right. For your standard V-prep on steel, you're usually looking at an angle somewhere between 30 and 35 degrees on each side. That's the sweet spot. It gives the molten weld metal the perfect path to flow in and fuse completely to those sidewalls. Next up is something that looks tiny but is a huge deal. The root face. It's that little flat landing at the very bottom of the groove. Think of it like a little shelf that prevents the intense heat of the weld from just blowing a hole right through the metal. And we're not talking about a lot of material here. This thing is tiny, like 1.5 to 2.5 millimeters. It's so small. But you have no idea how crucial that little flat surface is. It's everything when it comes to controlling that very first, most critical pass of the weld. Okay, our last key measurement is the root gap. This is the space you intentionally leave between the two pieces. Now, I know what you're thinking. Wait, we're trying to join them. Why leave a gap? Well, that little gap is essential. It's what lets the molten metal flow all the way through to the bottom. A typical gap is going to be between 2 and 4 millimeters. That's the gateway. It ensures the weld gets what we call full penetration, fusing the two pieces through their entire thickness, making them one solid piece of metal. All right, so we've got all these shapes, angles, and gaps. How in the world do welders and engineers pick the right one? Well, it's not random. It comes down to a really systematic process of looking at a few key factors. Let's walk through their thought process. First things first, how thick is the material? Thin sheet metal is a totally different ballgame than a thick structural beam. Next, what is the material? Steel and aluminum behave very differently under heat. Then you get practical. Can we even get to both sides of this thing? And finally, you have to match the prep to the specific welding process you're going to use. So, everything's been cut, ground, and set up. But before a single spark flies, there is one last absolutely critical quality check. You can think of it like the site foreman doing a final walkthrough. And in the world of welding, that job belongs to the welding inspector. Now the inspector? This person is meticulous. They've got a detailed checklist and they're checking everything against the official playbook. That's the Welding Procedure Specification, or WPS. They're making sure the surface is spotless. No oil, no rust. They're measuring every single dimension, the angle, the gap, that root face. It all has to be perfect. If preheating is required, you better believe they're checking that temperature. Absolutely nothing gets by them. And this really just says it all, doesn't it? If you rush the prep work, you're basically guaranteeing a bad weld. But if you take your time, if you're patient and precise before you ever start welding, that's how you make sure the final product is strong, safe, and meets the highest standards in the world. So next time you're driving over a massive bridge or you're standing next to a skyscraper, I want you to remember what's hidden deep inside. It isn't just solid steel holding it all up. It's a complex network of carefully designed shapes, all prepared with incredible precision. Those hidden grooves and angles, that's what's really holding our world together.